For this only exercise of the chapter, we're going to demonstrate polymorphism again with the shape class and two derived classes, rectangle, which we've already defined, and circle, which we're going to define right now. So we're going to write public class circle. It will also inherit shape. The only other data member we need is radius to go with x and y. So for the constructor, we'll have new x, new y, and int r. And then, of course, we'll call the base class constructor with new x and new y. And then in the body of the constructor, we'll set radius to r. To keep it simple, I'm not going to create anything else other than a draw method. So let's do that real quick. And we'll just have a string that says drawing circle at x and y with radius, and then close the class definition, because again, we're not really trying to spend a lot of time here on that particular method. I'm looking at the error. Oh, I see. I've got that parenthesis. That should clear it up. There we go. Okay. To demonstrate polymorphism, we're going to create a collection of shape objects. So we're going to write list shape. We'll call this shapes equals new list shape, open close parentheses. Now we'll create a couple of shape objects. First we'll create a shape, S1 equals new shape, and then we'll say 10, 20, doesn't really matter here. And then let's add that to the list. So we'll say shapes add S1. And let's add a rectangle. Rectangle R1 equals new rectangle. 1, 1, we'll put it in the very corner. And then we'll say it's 10 and 15 for those measurements. And then shapes add R1. And let's create a circle. C1 equals new circle. We'll say 100, 200, and a radius of 25. And then shapes add C1. And then let's put another rectangle in. Rectangle R2 equals new rectangle 200, 300, 20, 30. Shapes add R2. To demonstrate polymorphism, we're going to loop through the collection and call the draw method on each object. So we need a for loop for int I equals 0, I less than shapes dot count plus plus I, and then console right line shapes sub I dot draw. And again, here's where the polymorphism comes in, because the compiler doesn't know in advance what object is going to pop up when it calls shape sub I. So it's got to figure out what type of object it is and then call the correct method for that object. And then finally we want a console read key. Now let's run the program. We have an error. The error that we just saw was because I accidentally put public in front of class circle, which I can't do when I'm creating classes in the same program, in the same project. So I had to take public off, and then when I do that, circle then becomes accessible the way it should. So now we're ready to run the program. And so there we see that it does the correct method for each type of object. I have a little mistake there. I didn't put a space between the y coordinate and width, but that's neither here nor there. So once again, we've demonstrated how polymorphism works by creating a collection of objects and then letting the compiler pick the right draw method to execute based on the type of object that it finds at runtime. So that wraps up this chapter on polymorphism and more advanced object-oriented programming concepts. And now we're going to move to another data structure topic, and we're going to talk about arrays.